Again, welcome to this meeting. It's really not a class, it's more of a general process of how this thing is working. I know I already put a 9-minute video on the syllabus, so hopefully you guys would have had the chance to go through it. It's really gives you details also on how these things are working. But today is really to answer the format on how this class is going to be managed and how things are going to be done and things like that. I hope that some of you already prepared questions, and I already have things in mind to tell you about, because quite a few things, some of you I have never had them before. I know a few of you, I had them for Physics 251 in the past, so probably they are a little bit familiar with the way I do things, except that it's a little bit different because of the fact that we're doing things online nowadays, so it's a little more than that. Okay. Canvas is really your best bet where you need to do stuff, everything. With the exception of homework, I already sent an email last week about how to sign up for that homework on Pearson. So I'm hoping that a lot of you did. I know last time I checked, there were 5 people. Let me check again if there are more who signed up for that. Hold on. And now it must be to sign in. Hold on, let me see if I can. There are 8 people right now sign in, about half the class, so we need everybody to be on the same page to start doing homework too, because that's where the homework is, and it's a big chunk of the grade, so you really don't want to miss it. So if you want to pass the class, you really have to do that part too. The book is the 15th edition. I know I've carried in the past 14th edition, but no more. We're doing the 15th edition for this class. The lab is going to be online. There is already lab 1 that is in there. Everything that you will see, or at least for the most part, the rubrics will be clear in terms of how things are graded. So I'm hoping that you guys would pay attention to the rubrics so that you know how you're going to be graded. As a matter of fact, you can give your work to somebody else or even yourself and actually grade it based on what you have answered. So that's basically what I want to tell you in terms of the labs. The activities are going to be online at some point. I'm not sure if we're going to do this in this class or not. In other classes, what I do, I ask them to build stuff and make things and actually at home and design things. And at the end, they submit them via videos. I'm not sure if we can do it in this class or not, but we will see. Okay. So that's the thing that I think we will be doing in terms of the lab. Let me share with you the screen in terms of how Canvas works. I know that you have had enough experience nowadays with this one, so probably you don't need much, but at least you need to know how this class at least is working. So share screen. Okay. Can anybody confirm to me that you guys are looking at the screen where it says College Physics 3-252-25?
Yeah.
Okay, so this is the landing page. Whenever you come to the class, this is what you will see. You are going to see the this page. It gives you everything that you need to know about the class and the grading policy. That's basically the syllabus, no more. Okay, in the bottom, I'm not sure if you can see it or not, but it shows you the course summary, the things that are needed and when they are due and things like that. So those are the things that you're going to be needing, but don't pay attention too much to this page, honestly, other than checking the overall information and things like that. The main page you need to be at is the models page, okay? That's what everything is. So the model page, as you can see, it's sequential. You cannot jump to something. Right now it's great because I didn't finish this task. I'm basically signed in as a test student, and I already completed the pre-test, which allows me now to move on and so on and so forth. Okay. What you see in week one is basically what you're going to be seeing in almost every week. It's the structure that you're going to be following, with the exception of this pre-test that exists only once. And as I mentioned in several messages already, it's not going to impact your grade. This is just for administrative purposes. They want us to do this thing, so I included that. But everything that you're going to see in this week is exactly what you're going to be seeing for most part for every single week. There is a discussion. Discussion basically, if I click on it, and open it as a student, of course. And why it's not showing me the video? Is it my screen that is? Oh, it's still loading. Hopefully it's not going to disconnect the internet. Okay, took forever. You see the video embedded in this page or not? At least one confirmation, please. Okay, very good. So basically, every time you come in here, you're going to see a summary of the chapter, the main ideas, what I think are important and things like that. If I'm going to do examples, they will be in here too. What you're watching for is key points. What you're looking for are discussion points. There will be 1 to 5 points. On average, there will be about 3 discussion points, okay, that you need to answer in the bottom of this discussion thread. Now, you cannot edit your entry, meaning once you watch the whole thing thoroughly and you know exactly the points I'm raising in there, I don't know how many upfront, honestly, to tell you that there will be only 1 or there will be 5. And I'm not going to come at the end and tell you the summary of it. So you need to pick up 1 or 2 or 3. On average, like I said, there will be about 3 of them. And they can come in the beginning, they come in the middle, they come in at the end. But just to make sure that you're following the discussion of the chapter and you're doing what you're supposed to be doing to successfully pass the class. So this is the purpose of it. It's part of the participation grade. This is critical. So at the end, you're going to answer the prompts that are asked in that discussion. A lot of the times I do answer these questions right there and there. So it's not really hard tasks to do. And if you have difficulty with them, just mention, hey, I know the issue was this, and I tried it this way and it did not work. What do you guys think? Okay. Now, you cannot see other people's input either until you enter your reply. So you're not going to rely on their input first to say, oh, this is the point, so I skipped the entire thing and I'm going to go to the end. So it's not going to work that way. So you really have to first respond, and you cannot edit your response. Now, if you see somebody's as entry that might help you, that's good. Or you see that they did it in a different way that doesn't work, you can correct it. So that's the whole point of this thing in here, is to get everybody engaged in the class and working together and things like that. This is graded. Most of the discussions are out of 5 points, okay? And this we will receive 5 points for it if you meet all the requirements for it, okay? So at this point in here, if I go next as a student, it's the following prerequisites. So I cannot really get into this section in here unless I go and do the discussion. In other words, I have to finish that one first. I have to submit there, okay? If I don't submit it, then I'm not done with this. So I have to go back and really watch the video and do the stuff that I'm supposed to do. And then the next is going, let me go back into the modules page to show you what we have in here. This is the summary of the key concepts. And this is a quiz that you're going to take immediately. Usually you have 2 chances at it. If you do well in one, you don't need to do the second one. If you need to take the second one, it's going to take the average of the 2, okay? And then this is the lab activities. Okay, the lab activities, they are out of a rubric that is clearly stated in there. Let me tell you what the rubric says. You have to put your name. There is a lab report form in there that you have to fill. You have to put your name as part of the requirement for the lab report. You're going to tell me what the summary of the lab report is. Oh, I'm sorry, not the summary, the objective of the lab. The objective of the lab, try to leave it toward the end, okay? When you know exactly what the lab is talking about, then do the summary. There is specific format for it that needs to be 2 sentences, and at least 2 sentences or more, and talking about the concepts that will be covered and so on and so forth, okay? It's worth 3 points. The first one is worth 1 point. And then there are a bunch of questions that you will see, question 1, 2, 3, 4, 5, 6. Each question is worth 2 points. And the points there are basically based on the fact that you have an accurate response, and also you have a complete sentence. Do not give me a yes or no. That is not a complete sentence. So you really have to be as clear as possible in your answer. The temperature, the length of the rod increases because the temperature has increased or is going to increase or increased or something. Complete sentence, not a short yes or no. It will increase. Yes, it increases, or yes. That's really not a good way of saying things. So units also are important. So that's how you get to your full mark for 2 points for the questions. Each table has a number of cells. Each cell is worth 1 point. So depending on the size of the table, you'll get a number of points. And again, there are also in the rubric, it tells you exactly what happens if you miss one or more entries in there, for example, in the table or in the questions and so on and so forth. Graphs, if they are included, they're worth 5 points. I don't think that there is any graph for lab 1, so you're okay. You're off the hook for lab 1. Conclusion is worth 5 points. Attachments are worth 6 points. In this lab, there is no attachment, so you're off the hook. The conclusion needs to be also at least 3 sentences or more, usually far more than 3 sentences, to be honest with you. You need to refer back to the objectives, whether or not your results confirm or there is a problem with the objectives that you set yourself to meet. It needs to include data. It needs to include errors. If you're saying it's compliant with it, it meets the objectives, with what much accuracy? I need to see numbers basically in the conclusion. That's how you wind up with the perfect score in terms of the labs. So this is in a nutshell, basically what everything in terms of how the weeks are structured. In terms of the exams, they are typically, they are problem-solving exams. If you have questions, for example, for the lab or the questions for the homework that you need to help with, please communicate with me and I will set up a special session where we're going to meet and record that meeting and again, post it on Canvas for everybody else to benefit from it. So that's basically what I'm hoping to do. I will have some, during the discussion session, some problems to discuss on how to handle them, on how to tackle them, and so on and so forth. But I will also tackle the key concepts from that chapter and so on and so forth, okay? The exams, they will be online, of course. There will be quizzes. Every week has its own quiz, but there is also the before the exam test, the exam itself, there is another quiz also that's part of the exam, and that's also on Canvas. The exam itself, I mean the actual written exam, which is a problem-solving exam, well, at this point I really didn't decide 100%, because I'm testing a tool on Pearson to see if it's going to work, whether or not to hold it on Pearson or to go back and revert and put it exactly on Canvas the way that I normally put the exams when I did 251 with you guys. So this is in a nutshell what I have in mind, and I'm open to questions now if you guys have any questions. Okay, question before I ask anybody. I mean, there's a pre-test, so please take it. I know quite a few, 7 people did not take it yet. So you need to finish it, take it before you move on.
Are we going to be studying those concepts in the pre-test throughout the semester, or is that just random questions that don't relate to anything?
They are the objectives, what you need to know at the end of the course, okay?
Oh,
They are
okay.
actually essential. So there is a pre and a post. So for the post, in the post exam, there will be similar questions that assess your ability, whether or not you met those objectives or not. For right now, ignore what they mean, honestly, because a lot of them are kind of, maybe you have never heard of them, but I'm hoping at the end of the class, you will know how to do those questions, okay? Anybody else has a question?
Someone just said something in the chat.
Okay, hold on. Okay, the labs, they're on fillable PDF file. Winter sent this the question. Probably he knows better than anybody what those labs look like. Oh, no, I'm sorry. I probably did not do that with this class. I'm sorry. Anyway, the point is the labs, they will be fillable PDF files. Let me try to pull one and show you how it looks. At least pull lab 1, okay? Let me try to do it. And it's a good question, Winter. Lab 1, because I'm still working on lab 2, okay? Trying to get the form to work. PDF file. Okay, let me put it in a big view and share the screen. Share. I have two screens, so I'm moving back and forth between the two screens. Share. Okay. Are you guys looking at a PDF file that says lab 01 on the top in the
Yeah.
Okay. So when you see a field in red like this one, that is a required field. So I have to put my name in there. Okay. Okay, I'm going to show you the book. Okay, hold on. Let me grab it. This is what the publisher sent me, okay? Somebody's asked another question. Okay. But let me show this, Robert, hold on a second, okay? So this is basically when you see a red field in here. So I'm going to put my name in here. So this is my name. And this is what I expect you to do too for your name. If you happen to work with somebody else, which is highly encouraged when it comes to homework, when it comes to labs, when it comes to everything else, okay? Andrew, what is that link that you provided for us? Can you tell me what that is? Because there's a bunch of codes in it. Ah, that's the textbook, okay. I don't know. I clicked on it and my computer is still loading the page, I guess. Oh yeah, that's the book. Looks, no, is that the 15th edition? Anyway, I'm gonna show you what that looks like anyway. So let me go back into the PDF file. So the objective, as I said before, try to leave it toward the end, okay? Okay, so is there a problem with this objective? Hold on, okay, because I think there is a problem right away. I'm glad that. Okay, that's no good. I'm gonna fix this file. Okay, it has an issue a little bit, so I'm gonna fix it because the objective is supposed to wrap as a page. So right now it's not wrapping, so I need to fix that, okay? And now since I mentioned that, most likely the others, because they are copied off of this field, so I have to fix all of them. Anyway, I have to fix to do the objective, but before I do the objective, these are the questions that are worth 2 points each. Okay, if you skip one question, I mean, it's up to you if you want to lose the points on it. So the 2 points here and 2 points there and 2 points. So we're going to read the question, try to understand it, go back to the textbook and see if you can answer it. If not, ask one of your classmates, try to work together on it and come up with an answer that fits the bill, that meets the requirement, okay? So now we have done that. Now we're coming to the table. This table has how many? 1, 2, 3, 4, 5. And 5 times 4, that's 40 points worth in this case. No, was it 5 times? No, it's 20 points. I'm sorry. 5 times 4 is, yeah, 5 times 4 is 20. I cannot do the math quickly near enough. Anyway, I have different elements in here: aluminum, copper, iron, silver, and tin. Where you take it basically, let me show you the simulation since we are talking about this specific lab. It's a good idea that I show you that too anyway. So let me stop sharing the screen and share with you. This is not supposed to be a discussion for the lab, but since we're here, let's do that anyway and share with you this screen. So when you click on the link that is provided in that lab instructions, you're going to end up in this page. Do you guys see this page in here where it says experiment is showing an experiment? Can anybody confirm to me that too?
Yeah.
Okay, very good. So it says start with aluminum, so I'm going to start with aluminum. So I'm going to go back and here reset because I've been doing this one before. Since I'm starting fresh, so I'm going to start with a solid. I'm going to pick up aluminum from the bunch in here. I'm going to pick up a mass. It's really not telling me how much mass I'm going to take, but I have to take a mass that's going to submerge inside the liquid I'm going to pick up later on. The temperature has to be higher than 20 degrees. Doesn't matter what you want to pick, okay? As long as it's more than 20 degrees, you're fine. I pick up 150, you don't have to, you can do whatever temperature you like, okay? But you need to note these two numbers. You need to know the mass in your table, and you need to know the temperature in your table. So we're going to go next. We're going to now pick up the liquid. The liquid in here is going to be water. And it's fixed at 20 degrees Celsius, so you cannot change the temperature of the water, okay? And I'm going to take a mass that's, I know I can submerge in it that, not too much either, because too much liquid will take, it's not good, okay? The temperature gradient will not be too good, okay? There's a question actually that you're supposed, if you mix the two and you do the actual lab, you will run into a problem, okay? So you need to figure that out. So next. So now I noted the mass of the water. I noted the mass of the solid, which is in this case aluminum. I noted the temperature, and I'm going to start. Okay, I don't need to show graphs, but if I want to, I can show the graphs. It doesn't matter. Start. Okay, so that we're going to take the solid, put it in the liquid, and watch the temperature that was 20 degrees of this liquid increase accordingly, because the other one came at 150 degrees Celsius, okay? And it's going to reach an equilibrium temperature, okay? Because the way the specific heats for aluminum and that of water are known, I can find that the temperature is not going to be much different from 20 degrees. Actually, it's closer to 20 degrees, a lot closer to 20 degrees than 150 degrees. And that's expected because of the fact that the specific heat of aluminum is much, much, much lower than that of water. Water has a very high specific heat. So for the same heat that lowers the temperature from 150 to 25 degrees for aluminum, that heat went to heat the water from 20 degrees to 25 degrees, 25.13 degrees. So basically that's all I need for my table. Now I need to go and change I have to reset it and go back and find another material until I'm done with it. So let me stop sharing the screen, go back to the PDF file. So I have the PDF file. For the aluminum, I took its mass. I took the mass of the water. I don't remember. Water was 155 grams. This one was so many grams. What is it? 29.5 grams. The temperature of the solid was 150 degrees. The temperature of the equilibrium that was reached is 25.13 degrees. So if I'm doing this lab, I'm going to put the numbers. Don't repeat my numbers. Do your own numbers, okay? So so this is the temperature of the, this is the mass of the aluminum. The mass of the water was 155 grams. The mass, the temperature of the solid was 150 degrees. And the temperature where it came to equilibrium was 25.13 degrees, okay? So basically I have the entire row. Now I'm gonna do copper, I'm gonna do iron, I'm gonna do silver, I'm gonna do tin, and then come in here, use the formula that was given here to find the specific heat for aluminum. I have the mass of the water, the mass of the aluminum, the temperature of equilibrium was 25.13, and temperature of the solid in this case was 150. Plug in all the numbers, I should be able to come to this table and calculate the specific heat for aluminum. The table says the specific heat should be 0.215 calories per grams per degree Celsius. If it is the same number, the error will be 0%. If this is 0. whatever, so you're going to find the error in here. Just take this number minus this number divided by this number times 100, and you're going to get the 100% error. Then you're going to answer this question, and come to the conclusion and talk about everything. I need to fix this PDF file as soon as after the meeting today, because it's not behaving, at least the fields are not behaving the way they are supposed to be. So does this answer your question, Winter? And everybody else that you know. Okay, very good. So now to go back to Robert's question, which I think Andrew has answered, but just let me stop sharing that camera with you. If I go back to the other camera and remove this thing in here. Okay, that's the book.
Thank you.
Okay. So that's the book that we have for this class. It's Young and Friedman. I think, I don't know, the STEM Center used to have the 14th edition. I don't know if, is the STEM Center available or accessible or not?
It's not.
I don't think so.
No.
No.
Oh, man. I don't know if you, is that book that Andrew has shared with us, is it free or what, online?
Yeah, it's the 15th edition, the PDF. It's the same one I
Is it-
have.
Yeah.
Do you have to pay for it or what?
No. No.
Okay, I'm gonna ask another question. Is it legal?
It's
Found it online.
borderline, I'd say.
Someone posted it online. Probably not.
Okay. Okay, well, so let me go back into the other camera if I can find the other camera. Where is it? Yeah. Okay. So yes, so that's in a nutshell, basically. Do you guys have any other question? No. It's an investment, Winter. It's not suffering. What are you talking about? This simulation, I did it using something else. Actually, I have software for my astronomy class where I took the 4 planets, the outer planets, and I took also the hypothetical planet 9 and made them all very close from Jupiter. And in no time, within a day, all of them basically were collapsed on Jupiter, and planet 9, because I put it a little bit further, it took another 2 days or 3 days before it collapsed on Jupiter. That's for some of you who probably have gaming computers, you can get it through Physics Sandbox. I think that's what it's called. Anyway, any questions other than basically this few questions?
So there's another question about labs in the chat.
Okay. The PDF file, yes, it's part of the instructions. Okay, let me answer a question for Robert. Let me stop sharing this. Let me first of all remove this and find the page first, because there are so many things open. I don't want by accident to share with you something that is has some information that you probably. Okay. So let me share with you that screen. Right now you cannot see it because probably you didn't finish all the tasks, but I'm looking at it now from an instructor perspective. You guys look at this thing that says Lab 1 Introduction to Thermal Physics from the screen, from the canvas. Yes or no?
Yeah, we can.
Okay, so if you click on this link, that should be the PDF file. However, this PDF file, as I have said, will be changed today, okay? So I'm going after the meeting, you should see it working better, because right now the fields, they don't allow for the text to wrap. It needs to wrap, it needs to go back to as if you're filling another regular text. So right now it's not doing that. So I need to go to all of those fields and fix that for them and then update the file. So these are the stuff that I was talking about. For the lab, when you come into the lab, you will see this rubric. You will see how everything is graded. It's a good idea to, while you're filling the lab, to go through this rubric to make sure that you're not missing. Get answer in full sentence format with proper units when needed. Did I do that? If I did, then, and if I have the correct answer, then I should get this point. If I have some stuff missing, I didn't have it in a full sentence, for example, or I forgot to include the units, for example, then I'm going to get 1 point. If I did both, if I get the wrong answer, if I have no units, and if I have everything not correct on it, so this is how much I'm going to get in this question. This is question 3. There are a bunch of questions in here, and this is basically, you could follow the rubric and actually grade yourself. I don't even have to grade you myself, okay? So I'm hoping that immediately, this lab is due on January 29th, which is not this weekend, the next weekend. That's typical how things are with me. My stuff usually is due either on Friday or a Saturday. Okay, unless it's an exam, which is a different situation.
Excuse me. So can you get to this from the modules? Because I'm on my iPad and I don't have like the assignments tab on the side.
Okay, it's not the assignment tab, it's the modules. You have to go to the modules. Okay, let me go back and look at it from the student perspective. So this is what you see right now if you go to it. So let me go to the models. As a student, I have to complete this one, this one, this one, this one to get to it. Does this answer your question, Robert? Once you get there, you're going to see exactly. Sorry?
I got it now. It's I have to finish up first.
Yeah, so you have to finish them in a sequential order in order to get to it. The same thing with the week after, with the exception of the pretest, it's going to be the same format. Before you get to lab 2, that's what you have to do, okay? You have to do all of this in sequential order, okay?
There was also a question about how the tests are going to be like.
Okay, let me look at the chat, because while I'm doing sharing the screen, sometimes I don't see. Okay, the question for the exams themselves, first of all, I don't see the question yet, but it's fine. Let me answer it in. With what the tests will be like. Okay, the tests will be, I see it, the question, yes. The tests are going to have 3 exams covering chapters 17 through 20, and then 37 through 40, and then 41 through 44. Each one of them will be problem-solving questions, okay? Typically, in the past, and most likely this is going to be carried through, okay? I have 4 problems per exam, okay? Each exam will have 4 problems. And typically, either they're from the homework set or from the discussion. So whatever we do in the homework, a review for the exam. Whatever problems I discuss in the discussions, they're actually a review for the exam. So when exam time comes in, you need to review those things. And we're going to go through a review process before coming to the exams. As I said in the beginning, there is a chance I'm going to use the piercing tool that the publisher is saying that it's going to work well for the exam. It's still, you're going to answer the questions on a separate piece of paper on your own and scan it or take a picture of it with your phone or whatever, and then email it back or upload it, actually, I'm sorry, upload it to Canvas if it's on Canvas, or upload it to Pearson if it's on Pearson. So that's the exam at this point. There will be more details, but to answer the question in general, what I know for a fact in terms of the exam, 4 problems per exam, 3 exams, plus the final, which is comprehensive. I dropped the lowest grade. That's how the policy is usually with me in terms of exams. Does this answer your question? Was it Andrew who asked the question?
No, it was Caleb, but that was good.
Okay. 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 So I'm hoping that, unless you guys have any other, do you have any other question first before I jump to conclusions?
I have a question regarding the day we take the exam. So we'll just have the window just to take it throughout the whole day. So does that mean that it'll just be due at the end of the day, or we'll have like a specific time we're gonna have to complete it by?
Okay, because this is an online course, I have to account for the fact that some of you are working during daytime and they only have available nighttime, and others are actually doing the reverse. So the way it's going to work is it's going to come from the evening, let's say, for example, from 6 p.m. until 10 a.m. or 11 a.m. the day after, okay? So that's basically, or the other way around. It starts from the noon all the way to midnight or something like that to allow for that. But the due time for it is going to be toward the end, yes. So that's how it's going to be working. This is not, for example, I have other classes where it's called the regular meet, where the students are supposed to be on class in time, where we're doing Zoom live, and that is the exam will be exactly during those times. Okay, so you cannot work for those classes. You have to be full-time, basically attending all of those classes, whatever classes are supposed to be reg meets Now, Crafton has a different approach to this when it comes to that, and that is allows for the students to be online. So for me to do that, I have to accommodate for the people who are online. Yeah, do you understand the structure? So in other words, it's going to start in the beginning of the night, ending in the midday, or starts in midday, ending in the middle of the night. Does this answer your question?
Yeah, it does. Thank you.
Okay. But there will be a specific time. So if the exam is an hour and a half or 2 hours, you're supposed to submit it. So once you start it, you cannot decide to come later on and finish it. So you have to start it. So you have to really plan accordingly. So if you're working during daytime and you come tired at 4 o'clock or 5 o'clock from work, do not start it at 5:30 if you still have to go and probably look at the book and maybe refresh your mind and get something to eat and do some stuff. Start to try to start it later around 7 p.m. or something. That way you give yourself enough room. Okay. If you think you're too tired and too sleepy, do not start it. Let's say, for example, it's available at 7 p.m. or 6 p.m. Do not start it at 8 p.m. and decide to go to sleep and wake up in the morning to finish it, because they're not going to work that way. So it's going to be a fixed time. If you start it, if you don't submit it, it's going to submit it on your behalf, and that's not good. So you really have to plan those things accordingly. Okay. There will be usually an allotted time for the submission, because sometimes you have issues that might run. The file is too big, you send it, it doesn't go, which gives me another thing that I noticed some of you, at least, yeah, and Crafton were doing this, and they really need to improve on it. Try to learn how to optimize images. Okay, go to YouTube. If you have access to Photoshop, that's great. If you don't have access to Photoshop, there is a GIMP, which I use extensively now, where you can optimize images and make them run a lot faster and keep the entire basically the image basically resolution and all of the stuff. I mean, impeccable, meaning it's still very nice, but the file is super light. Okay, because if you come at the end and tell me the reason why I couldn't submit the exam is because I had problems with the internet, well, I'm sorry, I should have given you enough time to plan accordingly. So you really need to plan accordingly. So in this case, it's not an excuse. Okay. Any other questions? All of these questions are good. In terms of the math level, I don't know if you guys, how much you did in physics 251. I'd consider 251 the most involved math class in this sequence, because it has a lot of those integrals and a lot of the techniques used in it. In this class, there will be at some point, especially when we get into Schrodinger's equation and we get stuff like that, that might look kind of a little bit a lot of work, but Gaussian integral and all of these things are not really that hard to do. But this is not really, I mean, in terms of the algebra, for example, for relativity, it's not that hard. It's mainly linear algebra, which is really not that complicated at all. Winter asked a question, which is very important, okay? Probably we'll discuss this one when we do our first real problem together, maybe next week. I mean, I'm working on it for next week. The way I have problems basically done in the past with my students, and actually with my current students who are doing Reg Meets, is where you solve a problem, there is a 6-step requirement for it, okay, to show understanding. The first one is basically you state what was asked from you in the problem, or what you know from the problem. So basically the information that you gathered from the problem and everything else that you know was asked from it. This is what I know. This is what I was asked from this problem. Then you go to the next step where you actually find, usually it involves geometry. You have to draw something. You have to basically do some workflow, some diagram. some stuff like that. If we're doing physics 250, that would be the free body diagram. That's a good place for it. If we're doing, for example, physics 252, when we're doing relativity, maybe the time-space diagrams would be very useful for me in here, trying to understand the system, trying to find the relationship between, for example, the frame and the moving object and things like that. If I'm doing thermodynamics, that's probably the time when I'm going to draw a PV diagram and trying to find, they ask me about the work. What do I know? Did they give me the temperature? Did they give me the pressure? Did they give me the volume? What information I was given? So that is the time in step 2. I try to make a diagram, try to build an image, try to build something, and use the geometry, use whatever information, basic laws, for example, if I'm doing physics 250, F equals to ma. If I'm doing relativity, Lorentz transformation. If I'm doing, for example, thermodynamics, the ideal gas law, is the process adiabatic or is the process isothermal? So in this case, I need to know what the physics of the problem based on the question is, what kind of physics I'm going to put, what kind of math I'm going to put, what kind of geometry I'm going to put together. Now, that's stage 2. So there are 2 steps already I've went through. Step 3 is to actually solve the problem from what I know, trying to answer the question that I was asked. And in doing so, I have to justify every single step with mathematics, with physics, and try to basically talk out loud on the paper, of course, writing what I'm saying, so that to show that I know how I went from this step to that step to that step to the final step. Okay, so I'm going to solve, and the step 4 is justification. I have to justify basically my steps. Okay, so far I have covered 4-step process in solving my problem. Step 5 is to actually answer the questions. Remember, I solved the problem from step 3, okay? Step 4, justifying it. Step 5, now I am going to answer the questions that were asked for me in the beginning, okay? I have basically fulfilled the promise of the problem. I have answered that question. Step 6 involved discussing the solution. Does it even make sense? Okay. You ask me to find the tension in the cord. Is this tension too much, for example, for the cord to support it? You ask me to find the velocity. Is the velocity greater than the speed of light? I'm doing relativity now. Oh man, it is more. So I must have done something terrible. Okay. Is the engine is going, the efficiency, it says it can never be greater than that of Carnot cycle. What is this efficiency? Carnot cycle is giving me 23%, and this one is giving 27%. Does it make sense? So when it says does it make sense, you connect it, first of all, the problem itself, and see where you can apply it and things like that. That really shows understanding. That really shows, goes beyond that. If you have a question like this one in an exam, I'm confident 100% that you're not gonna have difficulty with it. You can resource, you can check the resources. There's all kinds of resources where problems from the textbook are solved. But if you don't understand them, if you don't go through this process, you will never learn them. You will never be able to do them in an exam correctly, and you will never be able to remember anything from it at the end of the day. So that's what Winter is talking about, and I'm going to try to implement it with you guys when we do the problems discussions. And I'm hoping that you guys also will be doing that, since the problems that are going to be done in Pearson are not going to be, are going to basically follow just as the answer correct or not. But I'm hoping that you guys will develop also this habit, so that to go through the process and show understanding, you understand exactly what the solution is, because come exam time, come later on, these are the skills that you're going to really value at the end of the day, because whether or not the I don't know, I'm trying to think of a problem in here, that engine, that cycle is good or not, how you were able to find the entropy for that process or not, that's a different question. But because you can find it later on in Google probably, oh, I forgot the definition of what the entropy, what was it again? You go and find it in Google. But the process itself and how you solve these things, that what I'm hoping you will retain from this class too. Okay. Great question, Winter. Anybody else? It's not clear probably to every one of you, but I'm hoping, to a lot of you probably, but I'm hoping down the road it becomes an easier way. I probably should do the following. Do you guys want me to write something on how this process works? Because I just mentioned it, but probably it's not going to be remembered.
Yeah, that'd be great.
Yeah, I will post something on Canvas talking about the process and give some examples, and hopefully you guys will apply it. Okay. Any other question? So the concepts that we're covering in this class are three things: thermodynamics, which is a science that was discovered in the 1800s, 1826, I think, when Carnot starts the question. And then later on was formulated in the 1840s with the first law. And then immediately they discovered that they needed the 0th law before the first law. So that's thermodynamics. It has a lot of implications and importance. It's by far probably the most important science you're going to learn in this class, because of the fact that it has applications everywhere you go. Everywhere you can go there is thermodynamics in living organisms, in biology, chemistry, physics, engineering, economy, life, and even religion. Whether or not God exists or not, people go back into entropy and try to find it or not. So it's really a big deal. The problem, for example, of a black hole, whether or not the black hole will obey the second law of thermodynamics, was really a big deal for a lot of debate. And it was Hawking who solved that problem, basically, in terms of the second law of thermodynamics. So this topic is a big, very, very important one, although it started a long time ago, but it's still an ongoing issue. And I think, and a lot of people actually have that the reason why time flows only in one direction is because of the second law of thermodynamics. The reason why we can move from today till tomorrow, but we can never go back, is because of the second law of thermodynamics. There are all kinds of things in here, and there is philosophy and religion. Everybody's involved in this branch of science. And I'm kind of a little bit, to be honest with you, hoping that this topic goes immediately after you learn about F equals to ma, because it's a little bit based on F equals to ma, than having to do electricity and magnetism and all the things, because it makes understanding chemistry and whether or not a living organism will do something or not is based on this law. Whether or not you will be able to basically have a successful machine or not really has to do with the second law, thermodynamics. So this is one topic. Then we're going to spend a chapter, which is kind of disappointing, on relativity. After that, it's going to be a special theory of relativity. It's not going to be general theory of relativity. Then after that, we're going to get into quantum mechanics. First of all, atomic physics, quantum mechanics, and then nuclear physics, and solid state physics. So those are the stuff that is, it's a big stuff. I mean, it's a lot of topics. A lot of these things require a little bit more work in terms of the math, but a lot of the times you will just basically go through them very quickly and move on. Okay, so those are the topics covered in this class. I don't do PowerPoints, so if you're expecting PowerPoints, I'm sorry, I don't, honestly, I tried it. Did not work for me in this type of classes. It works beautifully in an astronomy class, for example, or general physics class, but not in this kind of classes. Because to go from one step to the next step on an integral, if I'm going to do it on a PowerPoint, probably I have to spend maybe several slides. Okay. Any question? So do not try to do the lab until the end of the day, okay? Till I fix this issue first, okay?
Okay.
Okay. So if you guys don't have any questions, please do not hesitate to send me messages via Canvas through the inbox. I respond to those as soon as possible. Sometimes on the weekend, I'm a little bit busy or doing some other things or something else, but I try to respond to them as soon as I basically see them. I have a watch that shows me stuff, so usually I know about those messages immediately. And if that doesn't work, you have my email address. If not, in the past, I posted my phone number, and then I started receiving all kinds of phone calls from all around the world, basically about my warranty for my car expiring and my accounts with banks I don't even know existed, that they are somehow jeopardized and I have to log into them and all kinds of things. So I decided I'm not going to put my cell phone anymore. Okay, I'm sure you guys are also receiving these messages too.
Yeah.
Yeah.
Last four digits of your social security number.
Yeah. I mean, I have banks that I don't even know existed that somehow my account with them has been stopped or something. I have to log into the account so that they can fix the problems. I don't know. So, but other than that, you have my email. Did I post my personal email or not? My personal email should be fine. I'm going to post it in here in the chat, and I'm going to put it also in the on Canvas. Here is my personal email, just in case if there is a problem with my school email, or if you think you want to CC it. Okay, it's my first name at my last name.net, basically. Okay. I wish you the best of luck. Please let me know if there is any issue, if there is any problem you think you need to have discussed. If you try to do something on Pearson or before you do it, you didn't understand the question, please send me the question. We should be able to discuss these things and get things moving, okay? I have a camera in here, camera in there, camera in there, so sometimes I don't know which camera is it pointing at. We're good? Should I stop the recording now? No problem. Okay, so we're going to stop the recording right now, and I wish you the best of luck, and please communicate, okay?
Thanks.
No problem.